This paper explores techniques to improve the performance of large language models, LLMs, in software development tasks. What are the key challenges that LLMs face in these tasks?
LLMs are often used in software development for tasks like code generation, bug fixing, and documentation. However, these tasks often require complex reasoning and multi-step workflows. This means that LLMs need to be both accurate and efficient in their inference. Additionally, the cost of running large LLMs can be a significant barrier to adoption.
So the paper focuses on optimizing inference. Can you explain the different techniques explored in the paper?
The paper evaluates 3 inference optimization techniques: best of N, BARN, mixture of agents, MOA, and Monte Carlo tree search. Each technique aims to improve the performance of the LLM by using multiple calls to the model with different prompts or strategies.
Can you elaborate on how each technique works?
Best of N BON generates multiple responses to the same query and then selects the best response based on a scoring function. Mixture of agents, MOA, generates responses and critiques of those responses, then uses this information to generate a final improved response. Monte Carlo tree search, MDMATIS, explores different dialogue states by generating multiple queries and responses, ultimately selecting the conversation with the highest quality score.
It sounds like these techniques offer different trade-offs. Can you discuss the key differences in terms of performance, cost, and complexity?
Yes, the techniques have different trade-offs. Best of any is the simplest and most cost-effective, but it offers the least performance improvement. Monte Carlo tree search is the most complex and expensive, but it can achieve significant performance gains. Mixture of agents strikes a balance between performance and cost, offering substantial improvements while remaining relatively efficient.
The paper highlights the mixture of agents MOA approach as the most promising. What makes it stand out?
The paper found that MOA significantly outperformed the other techniques, achieving a 15.52% improvement on the ARENA hard auto benchmark. This means that a smaller, less expensive model using MOA could outperform a larger, more expensive model like GPT-4 Turbo. MOA's ability to generate critiques and refine responses seems to be particularly effective in improving the quality of the LLM's output.
That's a significant finding. Can you elaborate on the specific software development tasks that were evaluated in the paper?
The paper evaluated MOA on a variety of software development tasks, including code generation, bug fixing, documentation, and pull request review. The results showed consistent improvements in performance across all these tasks.
So MOA seems to be a versatile technique. Are there any limitations or challenges associated with its use?
While MOA offers significant benefits, it does require multiple calls to the LLM, which can increase the overall inference time and cost. However, the paper argues that the performance gains outweigh these costs, especially when considering the potential for using smaller, less expensive models.
The paper introduces the term patched MOA. Can you explain what this refers to?
Patched MOA is the name given to the specific implementation of the mixture of agents technique used in the paper. It's designed to be easily integrated into existing LLM pipelines and is transparent to the end user.
The paper mentions patch flows. What are these and how do they relate to patched MOA?
Patch flows are automated workflows that use LLMs to perform specific software development tasks. The paper evaluated the performance of different patch flows using both a base model and a model optimized with patched MOA. The results showed that patched MOA consistently improved the performance of these patch flows.
This suggests that patched MOA can be a valuable tool for improving the efficiency and effectiveness of software development workflows. What are the potential implications of this research for the future of software development?
This research suggests that inference optimization techniques like patched MOA can significantly enhance the capabilities of LLMs in software development. This could lead to more efficient and automated workflows, potentially reducing the time and effort required for tasks like code generation, bug fixing, and documentation. It could also make LLMs more accessible to developers with limited resources.
The paper mentions that patched MOA is available through an API. Can you provide some details about this?
Yes, patched MOA is available through an API at patched.codes. Developers can use this API to integrate patched MOA into their own applications and workflows. The API is compatible with OpenAI's API, making it easy to use with existing tools and libraries.
To wrap up, can you summarize the key contributions of this paper?
The paper introduces patched MOA, an inference optimization technique that significantly improves the performance of LLMs in software development tasks. It demonstrates that patched MOA can outperform larger, more expensive models like GPT-4 Turbo while using a smaller, less expensive model. The paper also shows that patched MOA can be easily integrated into existing LLM pipelines and is compatible with OpenAI's API.
This was a fascinating discussion on the potential of inference optimization for LLMs in software development. Thank you for sharing your insights.